My name is Robert Cross. I'm the principal of Cross Consulting and Outfit, the design studio that helped put this together with Tao. This segment's dispatches from the energy transition. I'd like to introduce everybody and bring them up on stage, starting with Lucas. Lucas Miller is the senior engineering consultant with Mayfield Renewables, an Oregon-based company. And joining him on stage is Adib Nasle, co-founder and CEO of Xendee. And next is Jason Carver, director of engineering at Ameresco. And last but not least, Nate Hill, head of energy policy at Amazon. Lucas, what are we talking about today? What's the subject?
Well, we've already covered a lot of ground today. We've seen quite a few lightning talks. We're going to really follow the back half of today's event is two longer form panel discussions. So this first one here, we're going to be focused on data centers and AI data centers. A picture says 1,000 words. We are trying to plug a very, very large load into potentially a small outlet. So we're talking here today about how we can make that happen and how we can do it sustainably with the overall energy transition in mind. So we're going to open up here, kind of setting the table. What is the pace and scale of AI data center development really look like? And Nate, I want to start with you. This chart here, we pulled from 2024 data. Really want to draw your attention to the second biggest bar there, which may surprise some people. I know it's been mentioned earlier, but Oregon is really a hotbed for data center development. And so Nate, I'd turn it to you to give us a sense of the overall pace and scale nationwide, what's driving that, putting some numbers to it, and then why is this region in particular such a hotbed?
Okay. Well, this is a surprise. I thought I was here to talk about Prime Day and what's on sale, but I guess I can pivot at the last minute. You heard, you actually heard Brandon talk a little bit about this in the beginning of his remarks. Historically, the Pacific Northwest has a lot of advantages. You heard, in addition to the fiber network, there's also the Trans-Pacific cable that comes into Oregon. Historically, there was an infrastructure build out that benefits everyone in the region, including data centers. And there are communities that were willing that wanted to do economic development and scale and do industrial development, water resources, land. So just a lot of elements sort of came together over the last decade that made this a really attractive region to build. And that has led to our $30 billion investment in the state over the last decade, 7,400 full-time jobs, $15 billion economic impact to GDP, and just I think overall it's been a really good story. And I think one of the those are several factors that I think have been positive and led to a lot of data center development here in the region.
Jason, Ameresco's perspective, something that I really like that I think we're seeing today. Yes, there's a lot of challenges, but there's also innovation. What is Ameresco's vantage point on opportunities with data centers over the next few years?
I think I'll just go back to what I heard earlier, which is any and all of the above. So when you're trying to power something like a data center, I love the graphic that this started out with, it seems impossible. I mean, there's not enough energy to do that. But actually, I think if we keep everything on the table, there is. We're going to get through this. So when we look at something like a data center, maybe Ameresco is a technology company or a clean energy company. We might be the icing on the cake for a data center. We might be just doing solar panels on the roof. We're working with several of the big companies in the room right now doing that. But we also might be part of the primary solution, whether that's renewables, whether that's combined heat and power. But I think every challenge, every data center that needs power is going to have an opportunity to do something innovative, whether it's solar to offset peak batteries or being the heart of the solution. So we like to be involved in these conversations early, just so that we can add value to it. We can maybe get the project over the hump. We can maybe be a political ally. The more renewable, the more likely things are going to be built in Oregon. So we like to be involved in these opportunities, even though we might not be and often won't be the primary solution provider for them.
And Adib, representing Xendee as a modeling and optimization software, how important is the planning stage of developing these giant resources in terms of not only the financial aspect, but the engineering and energy modeling that goes into developing potentially a 100+ megawatt site?
I think the planning becomes more and more critical, because as the size of the energy power plant goes and grows to the intensities that we're seeing, small inefficiencies become very big numbers. So sophistication, but at the same time having the speed to be able to iterate through different scenarios and use cases, so that the economic justification, the decarbonization opportunity, and really tweaking out those costs while delivering a high level of quality in the power, along with the financial outcomes, to make sure that those projections are actually going to be able to be realized in a reliable and consistent manner, makes planning that much more critical. And I have to, just mention here that Amazon, Ameresco, and Mayfield are clients of ours, and they leverage our technology on the planning side. We're really proud of having this chance to work with world-renowned organizations like them in addressing these power gaps, and also the opportunity for innovation with on-site generation technologies has been really, really rewarding.
I want to throw this question out to the group, just out of curiosity. I know that Northern Virginia is Data Center Valley, and you see other locations up here, but how does that work? I mean, how do we determine where these data centers are going to be, and who wants to touch on that?
I guess I'm probably the natural one for that question. Yeah, I mean, so, there's a process that all data centers kind of go through, and an approach that we take to find the right. But I mean, historically, when we're doing data center services, we look for those elements that I mentioned earlier, Brandon mentioned. Really important to be in communities that are sort of economic development focused, growth focused. But then you need to have the infrastructure there to grow and to cluster. And at the end of the day, we're trying to drive cost out and ultimately to serve our customers. And so, we've gone to regions that are looking to grow with us and looking to be partners in that growth. And it's a partnership that has been successful, mostly, early days in Virginia. But more and more, there's just such overwhelming demand for data center services. You heard others talk about language models and traditional data center services, online banking, Netflix, search. It is modern infrastructure, and the demand from customers and public and state agencies and federal government and everyone it's still there in a very big way. And so I think that's why you're seeing more and more cities and towns and regions looking to partner with data center operators as well, and learn from what others have done in the past.
So when I hear you speak about that, I mean, there's the power demand issue, but it's also an economic development play, right?
It is. Yeah, it is. It is. It is it's a contribution to the local tax base. It is oftentimes, I can speak for our model, we'll come in and offer STEM education training. We'll make grants to local nonprofits. We have a whole teams built around being a good community partner when we go into a region. So even when we grow and we cluster, we can scale those programs and work with the community colleges and the local lawmakers and politicians. So it scales too.
So I want to bring us down to a bit more of the facility level. And Adib, I'll start with you. I think up to this point, we've used the term AI data centers quite a lot, and I think in reality that might be an umbrella term with a lot of categories underneath it, from hyperscalers on one end to grid edge, small scale distributed data centers on the other end. How do you describe that to folks, and what are the key segments within this AI data center umbrella as you would see it?
Well, I mean, looking at it from the high-level energy load shape view, there's the ongoing data center workload that I think we all use, whether it's Netflix, software as a service applications, and those have a certain intensity and a shape, and those are going to continue, and more of them are going to be needed. And then we have the actual data centers coming on for training these AI algorithms. And those just require a whole different level of energy. And I think the earlier panel described going from 1 kilowatt to 2.5 kilowatts, and it's projected to be 12 kilowatts or more for these GPUs. So essentially, you're taking a lot of energy, turning it into heat to learn or help the algorithms learn. And those are the ones that are on the other extreme end. It could be from 100 megawatts to gigawatts that are just this massive load that has to be served. So that's kind of how we look at it, is the inference, where it's the consumer facing, and then the training component. And I would say probably 70% of the data centers and so forth will be the customer facing ones, and then 30% will be these really, really big training loads. And those are all growing, and they're all projected to grow very fast over the next 7 to 10 years, depending on how the business models pan out. But that's how we look at it, is there's the AI load for the training, and then there's the consumer-facing workload that the data center needs to address, both from heating, from the cooling and electricity component.
So as an electrical engineer, us at Mayfield, we often look at load shapes and load profiles. And so maybe a school, as a simple example, 6 a.m., the building's been empty all night, very low load. People start coming in, school day happens, people leave. It's a step function. But it can vary quite a bit depending on your facility, depending on your industry. And so, Jason, I'd turn this one to you for data centers and in general. How does the load shape change how you as a developer approach the energy infrastructure to power the system, or maybe introduce energy storage to smooth some of those peaks?
Yeah, that's one of the areas we like to look at, is finding opportunities that are cost effective in powering the data center. Not all kilowatt hours are created equal. A kilowatt hour at 1 a.m. may not be very expensive because nobody needs it. But data centers do. The AIs, the chips, they don't care what time it is. So that would be a cheaper time to be running processors. So the only way to shift what is typically a constant load at a data center, there's no reason to turn it off at night. Most of it's automated. So you can store energy when it's cheap. So you could borrow more or buy more power from the utility at night, and then you could use that to, you're not shaving a peak on the data center, but you're addressing the peak in the grid when the power is going to be more expensive. And that's going to continue. I think we've seen a lot of utility tariffs move toward a demand-based rate, where the kilowatt hours are actually not that expensive anymore, but the kilowatts are very expensive. So although the data center curve, they're using about the same amount of energy all the time, it's pretty consistent, it's not always the same cost. So that's where energy storage comes into play. And also solar is very effective at just, coincidentally being, it's not a coincidence, when the sun's out, it's creating that cooling load. But that's another thing that can help with that, just dealing with the costs of the grid on a time-based system, even though the load is constant.
Nate, we created dispatches from the energy transition to be a bit ahead of grid, right, edge of grid. And I spoke to you a little bit before the program, doing a little bit of homework. Lucas gets on me for that. So, future technologies. which one are you excited about and why?
Yeah, no, great question. I actually, if you wouldn't mind, I want to just speak a little bit about your comment. I mean, I think the grid is still underutilized, to your point. I mean, I think there's a lot of ways to better utilize the grid, and you know, we're a high load factor customer that can help with that, but I think there's also ways to enable technology, front of the meter, to basically fill in the gaps. Because, you know, there are, to both your points, there's an underutilization out there, and we need technology to optimize it. And hopefully there's a lot of folks in this room who are thinking about optimizing those systems and using technology to optimize those systems. And that's an area we're looking at too. I mean, you heard Brandon mention grid enhancing technologies. Those are about optimizing the existing footprint of the transmission system to achieve large scales. You heard Dylan at Google talk about it too. It's about speed and scale and optimization to sort of drive out cost. And that's an exciting technology. I think there's some exciting storage technologies in the near term to help solve those gaps. That can also be beneficial to even interconnecting faster. You could speed up the interconnection process theoretically with some storage on the grid to help with those times. But I think looking out longer term and bigger scale, I think we're very excited about small modular reactors. We've made sort of a large investment to accelerate a project in Eastern Washington. We've made a big capital investment in a startup called Xendee. And it's a very unique arrangement from a traditional sort of virtual power purchase agreement that a lot of hyperscalers do. This is using our balance sheet, our resources to help those entities accelerate the project, get through permitting, get through licensing, give them capital and runway in that early stage that can be more challenging. So that's just another one that we're excited about in the sort of mid to longer term, but I think that could really scale and be exciting as well.
Adib, when I hear Nate talk, we have present technology and future technology. We've been in San Diego several years ago, and part of what drew me to the Xendee platform is how you can work with both, right? Can you talk a little bit about that?
Yeah, I mean, the technology innovation is definitely at the heart of this whole energy puzzle piece, and I'm biased. I think microgrids are one of the probably most effective ways of addressing the power gaps, while at the same time bringing the flexibility to introduce new technologies like SMRs. So and at the same time make the acceptance of these large loads into the grid much more efficient. Because it's one thing to serve the load, but what happens when the load just drops off as well? I mean, data centers, they sniff a problem in the grid and they island. And usually they're clustered into campuses sometimes. So if you have gigawatts just all of a sudden disappearing, that can create its own set of issues. And so microgrids, I feel, as a technology, not only can chop away at costs and deliver the reliability and resilience that's needed, but at the same time make these big loads grid friendly, where you can actually actively shape your load and how you're going to look to the grid at any moment, at any time. And it's not just about serving the load, but if you also need to get off the load, you can do it in a way that doesn't impact the rest of the community and the surrounding areas that are relying on that grid. And I think one of the great innovations from SMRs all the way to the battery technologies and everything else that we're seeing, including geothermal heat pumps, different ways of addressing even the cooling needs through absorption chillers, these all bring the flexibility to adapt to different environments and geographies that developers want to deploy data centers into and serve their customers in the most cost-effective and reliable way possible.
You mentioned efficiency gains there, Adib, and Nate, I want to ask you about DeepSeek for a moment. This was something that back in January, Chinese R&D lab announced kind of out of the blue that they had developed their own AI model that in a lot of cases surpassed performance of US-based models. And I know that I'm seeing maybe on some metrics, maybe not on all. My question for you, Jason, and I'd open it to the whole group, is are we potentially overbuilding these sites? Is there a future where our AI models get so efficient that we build a 100 megawatt AI data center and we only need 10 megawatts to actually fulfill what we need. Is that a realistic future? If so, how do you address it? Or do you maximize the full 100 megawatts that you have available?
Well, this is kind of one of those things where if you shoot for the stars and you miss, you land on the moon. There's growing demand for electricity, and I don't see any near-term overshoot that's going to be terribly problematic. AI, to me, and kick me, it's kind of a brute force way to figure things out. It's try everything. We don't know what the answer is. Just compute everything, and then give us the one thing that we need. So there's obviously incredible room to make it more efficient, but I think with the growth, with the need of power for industry in general, and with the limitations of a traditional grid, I don't think that's a worry. It's a good question, though. You didn't prep me with that one, so.
As much as we go off script a bit, Ryan's better at staying on script.
Yeah, I'd love to hear your thoughts on it too, Nate.
Yeah, no, it's a great
AWS
question.
perspective.
But I'm aligned. I mean, I think that we're in an era where we're seeing more electrification. From our own perspective, the demand from our customers for digital services, training models, machine learning, it's still incredibly strong. And every efficiency that we eke out in the way we build and the way we design is allowing us to fill in customers and serve those customers bigger. So I think we're incentivized in every way to build in the most efficient way possible so we can keep serving those customers. But even if you theoretically overbuild, there's so much more electrification happening in broader society, to the transition to electric transportation, more electric building envelopes, just different. I can even speak for our own fleet. Like we're turning over our delivery fleet in the last mile to 100,000 electric vehicles in the next 4 years. So that's requiring extra electrification. So I think there's a lot that can fill in the gaps, and I'm less worried about overbuilding.
So I'm slightly biased to microgrids, so I'll throw this to Jason and Adib a bit. What is the role of a microgrid in this arena?
Well, I'll touch on the first question and then on this one as well, because I think they kind of play with each other. That gap has to get filled. I don't see organizations putting their business execution risk at the time scale that a utility wants to move at. And if we think of the grid as a machine, it's been built to address a certain behavior, and now we have a different set of behavior appearing. And to me personally, I mean, this feels like a massive arms race, but it's not military, where a lot of money, I mean, we're hearing about SMR investments, billions of dollars being put in. There's a reason behind this. Nobody wants to be number 3, and certainly everybody wants to be number 1 in this. And then when you consider the onshoring of chip manufacturing, pharmaceuticals, and critical supply chains, I mean, just robotic welders, I mean, the amount of energy that you're going to need to address all of these different critical supply chains, in addition to the compute load that, to me, feels like a non-military arms race, that power gap has to be filled, and people aren't going to wait 7 to 15 years. The game is going to be over. So you got to meet the power need, and it is a power game, because to train these models and to train them at the speed and the intensity that's needed and to remain in front requires a level of energy demand that you can't wait 7, 15, 12 years, 5 years for a queue to open up for you. So you got to take what you can, fill the gap as quickly as you can, but at the same time have that flexibility to absorb new technologies like SMRs. So the role that the microgrid plays in this entire landscape is, A, it can fill that power gap. Number 2, it can do it in a way that is flexible to meet the organization's goals, cutting the costs, getting the emissions down, and delivering the quality of power from a reliability perspective, and doing it in the time scale that you need. The third is, at the same time, it allows these loads to come on not only faster, but it's almost like an active suspension system. You know, you're going to have potholes, but you hit a big pothole and you don't have an active suspension system, you might crash. Microgrids, they smoothen these to the grid. So to the grid, these loads coming on and off can be shaped in a way that almost like an active suspension on a car. You feel very smooth ride and comfort without realizing necessarily what's happening behind it when the tire's hitting the tarmac. And the third is really the economics of it. And that really comes down to a few things. One is with a microgrid, you're generating the electricity yourself. You're kind of controlling your business case. And when we're talking the type of loads we're talking about, I mean, little numbers become big numbers. So being able to cut costs becomes really, really paramount, and doing it in a reliable way. So those are the ways that I see a microgrid really addressing, not only filling in the power gap, but providing the flexibility to absorb these new technologies, whether they're SMRs, new inverter technologies, new battery technologies, whatever new generation, linear generators, fuel cells, take your pick. Not everything's going to work in every kind of geography, but you kind of need to have that flexibility from a real estate perspective to deploy where you want. And microgrids really give you that flexibility along with those other additional benefits.
Yeah, I'll just add really quickly, just to emphasize your point about the need is now for these systems. So, what I tell young people when they ask for career advice, I always just say, just do something. It doesn't matter that it's not the perfect thing. If you're not moving upward, it's very hard to move from where you are very vertically and then to the side. You can always move laterally. So just like with data centers, you have to do something now. You can't wait for the grid to catch up. The utilities were never meant to be scaling this quickly. So what you can do is you can, all a microgrid is, it's really hard to define. It's generation, it's demand, and it's the controls. So in, kind of generalizing microgrids, it's doing something. It's figuring out at least what can we generate ourselves, how can we interact with the grid, and, at least get some of our demand answered. So, and also back to the technology question, whether it's a, SMR or, traditional type of power generation. If it's not available now, do something that makes you ready for that new technology in the future. Build in that flexibility, have a plan, make things modular. That's right in the name of SMR, to do something, because you're going to get left behind. You're going to be third, fourth, fifth.
And I mean, when we were earlier talking about potentially overbuilding, I think the risk is actually on the utility side, because folks are going to fill that power gap. They're not going to wait. So building out something 7 years, 10 years from now to meet a projected load growth, and people are already generating their own power, they're already storing their own power, they're doing cogeneration, trigeneration maybe. The risk is that the grid asset becomes a stranded asset actually in that case, because you're able to repurpose a lot of that on-site generation once an SMR or some bulk power supply capability comes on campus to provide that redundancy and backup capabilities that you'll need, and also the fast-moving dispatch that you'll need. Some SMRs are claiming they can do load following, and but regardless whether they can or can't, having these fast-moving assets on site really helps address even that component of it as well.
I think you're alluding to this a bit, Adib, and maybe this is the right moment for us to shift gears to this phased approach to developing an AI data center. And our main resource here is a Xendee white paper on this phased approach. And I'd open it up to you, Adib, to kind of walk us through how this approach works and why it's beneficial.
Sure. So we partnered with Idaho National Labs to develop a very sophisticated, first-of-a-kind, end-of-a-kind SMR model for techno-economic analysis and feasibility studies for project developers, planners, data center owner-operators to be able to use to really understand the economics and the technical design and the dispatch that would need to occur for these technologies to be adopted as quickly as possible. With that, we also worked with the University of Illinois, where they actually had a data center that we could use, get the load shapes on, and then to use that as a way to look at the potential for microgrids and SMR technology and different storage and generation technologies. And we looked at the two sides, West Coast and East Coast, because each has different strengths and weaknesses. On the West Coast, electricity is usually more expensive, decarbonization potential is lower for a microgrid because the grid is already very clean. And on the East Coast, the electricity is pretty cheap, but decarbonization opportunity is much greater. So we looked at both, and what was the best approach for an energy developer? In this particular case, we're looking at hyperscale data centers to be able to really address the energy gap. Was it to connect to the grid and wait for the grid to build out? Is it connect to the grid and wait for the SMRs and implement that? Or was it to connect to the grid, fill the power gap, and then implement the SMRs? And which one, and how did the numbers pan out, both from a environmental footprint and also economics? And we looked at Santa Rosa, California is one area, and the Data Center Alley in Virginia. And essentially what we, the study looked at was the investment, the sequence of investment, and the outcomes depending on those sequences. And in each case, the grid was, relying on the grid was actually the worst case. And being able to actually implement a power gap quickly and then absorb new technologies, whether it was absorption chillers, whether it was batteries, whether it was SMRs, just the numbers economically and also from an environmental decarbonization opportunity were always superior. So we published this white paper describing kind of the geographies, the load shapes, the assumptions made, and the outcomes. And this multi-phased approach was actually what kept on winning. And it was a science-based approach, so the algorithm has no bias. It's just pure optimization, mixed integer linear program, and we give it the inputs, and it gives you a scientific view into what actually is going to achieve the economic justification and the environmental opportunity for decarbonization, along with the resilience that was needed. And on both sides, the three-phased approach was the one that had the strongest, most reliable outcomes.
Nate, following up on these two slides, kind of combining them together, I feel a lot of urgency, right? And there's innovation, but then we're trying to balance that with efficiency. It sounds complex. What is your vantage point about the balance between the tension of urgency, meeting demand, but doing so in an efficient way?
Yeah, I mean, you need both. I mean, you honestly need both. You have this large demand that you're trying to meet, and I think that demand signal is really important. I mean, it's the large demand signal that growth that Brandon talked about earlier from the 50s to 2000s, and now we're sort of maybe entering back into that demand. That demand signal is a signal to technology providers to optimize the grid, to build new technologies, to serve the grid, to build transmission and distribution, and that's really important. And I think it needs to be done in the most efficient way possible, so that you're spreading the costs across as many kilowatt hours as possible, and but you're not compromising your service to customers who are relying on the digital infrastructure that you're trying to build. Because at the end of the day, the customers that we're trying to serve expect a certain level of reliability, and it's important to keep that in mind, that when they're running a model or they're running their banking transactions or they're optimizing their business, whatever, they expect a certain level of reliability, and that's the demand signal, and I think that's what's driving more technology, more optimization, and that's why we need to do it all very, very quickly.
Jason, from engineers like to build things, what are your thoughts on this phased approach, just hearing it?
Yeah, that's kind of along the lines of my do something advice. You can't wait for perfection. I mean, I don't even want to mention nuclear fusion, because what that does is cause people to say, well, when that comes along, it's solved. There's no sense of when we can replicate the sun on the Earth's surface. I hope we do someday.
The New Yorker article said there was a breakthrough not long ago.
Good to know. So we don't want to wait for that, even though it might come along someday. So we work with what we have now, and there's a lot of usable solutions. We're going to find those, and it's going to be an all solutions on deck kind of thing. So there's plenty of development. Ameresco is working with SMRs on some of our new developments. We're partnering with terrestrial energy on a particular project. So there are things we can do now, and I don't recommend anyone wait for a technology that doesn't necessarily exist to start. And small nuclear fission reactors do exist, but there's challenges too. We don't want to talk those down too much. These concerns are real. So anyone that's not liking that part of things, we understand. So, but there are things we can do now because these things are needed. We're going to get beat globally. There's one thing being first from a business standpoint, but there's another thing being first as the peaceful, free world too. So that means that we do what we can now.
I think we have ample time for some audience questions. I don't know if you have any more for our group, Robert, but
Who's
we've
screening
exhausted
the
my
audience
list.
questions?
Hi, everybody. Thanks for being here. There's a lot of good that can come from these developments, but I really want to pose the question is, when is enough enough? Demand drives business, but at some point we have to make a decision as leaders within this field is when is enough enough? Do you understand what I'm asking?
That sounds like a softball question.
Okay.
Who wants to take a stab at that one? Lucas?
I mean, when are we going to stop needing more energy, more electricity, more generation of energy? Is that what you're alluding to?
Yeah, like the idea behind, we all participate in the consumption of this energy. I'm not naive to that. But at some point, are there conversations within your organizations and your corporations of, is there a moral and ethical responsibility to kind of cap how much access we have to data centers and how big these things can get before we do more detriment than we are doing?
I'll jump in while others are formulating a response. I think it's a really good question because we're always asking, how much power can we get, or even, what I do more of is how efficient can we make it. So there's not a lot of controversy in making something that we're already doing more efficient. But we don't often ask, what can we live without? It's a hard thing for us as businesses to really bring. Personally, I think it's a fantastic question. I would love a day where we kind of decide that this is good. This is a good quality of life. The world's peaceful. Everything is good. So maybe that's the end game. It's not, where we're at now, it's probably not asked enough. So I think I can just address it from a personal standpoint. Is I would like to be asking that question more, is when are we happy? And in small examples, like when we're doing an energy efficiency project for a school, can you live with 74 degrees as your cooling point? Your body will adapt. It'll be fine. And generally, they are. So I think in small bits and pieces, we're dealing with that. And data centers, you may have some regulation that says you just don't get the power that the public uses because it's driving up the cost for consumers. Or you may get kind of, they're market driven. So if there's things that are generally problematic for the public, they're going to adapt with the free market. So that's a tough question to answer.
I'll just add, that we take our impact incredibly seriously. It was one of the big drivers of our company founding the Climate Pledge. That's our net zero commitment by 2040. We co-founded with Global Optimism, and we've since signed up 600 other companies to sign that pledge and to achieve that same target of net zero carbon by 2040. And in order to operationalize that and to get there, the demand from customers helps achieve that, but it enables us as well to invest in the clean technologies that we're going. We've to date, we've been the largest corporate purchaser of wind and solar and storage for the last 4 years. It's been 600 projects just north of 30 gigawatts around the world. And a lot of those are in places that have some of the, the most fossil heavy grids, India or other parts of the world. So I think it can be both. I think we can grow, we can serve customers with the digital services that they want, but with the long-term view that it can help enable the clean technologies that we're going to need to hit that net zero carbon target.
And myself personally, I feel like I'm just sometimes a passenger in a ship. And the ability to influence, to say, only use this much or don't use this. But really, we built the company to give folks and businesses the tools to be able to do what they want, but do it in a way that is clean, sustainable, while at the same time has a business case. Because I learned early on, no matter what you want to do or say, if it doesn't have an economic justification, it's not going to get adopted. So how can we make the generation, storage, and dispatch of energy as clean, reliable, and economically justified as possible? And that's really what we built our software technology around, was to give people the tools to do the right thing to meet their business objectives overall.
I want to follow up on that question or kind of speak to it. I think Peter West is here. He worked at the Energy Trust of Oregon, and being a fellow Jersey boy, that's how I got my start in the industry 18 years ago. But what about innovation and efficiency? Or just thinking about energy efficiency? Curious in that regard.
Yeah, I think Nate's response was really good. Is sometimes these things start in industry and then they're able to go to the general public. It's still, on the edge of affordability, depending where you are, to have your personal life be fully powered by renewables. And with large adoption comes cost decreases. And there are examples of these types of discussions of how many people do we need in subdivisions and things like that, where we've kind of leveled off on certain things. So I foresee a day that we do level off on this and are able to, efficiencies are able to pick up the slack on the growing demand.
Is this where I can talk about the smart thermostats available on Prime Day, or is that later?
I mean, it's commercialism, but it's smart. Any other audience questions? The green, sorry.
I know Eric Schmidt. I haven't seen his testimony, but I mean, we're planning for long-term demand beyond 20. I mean, we think customers are still going to use, these services beyond 2030.
What we're hearing up here is the rise of electrification, AI, data centers, demand's growing. The forecast is, how's the forecast, Adib?
It's exponential. I mean, it's multipliers. It's not flat. And whatever I think energy efficiency gains we might be able to ease out, given the new future that I think we're all looking at, whether it's supply chain coming on back stateside, new compute use cases, new electrification of everything from transportation to what we've been witnessing just from the communication side. I believe a lot in science and technology. I really think we can address a lot with smart people thinking together globally. At the same time, the efficiency gains I think that we will still get consumed by more compute power. So even if you deliver so much performance per watt or per kilowatt, whatever metric you want to use, you're just going to have more work. I don't think the work's going to get less is what I'm getting at. And just to put it in perspective, when we looked at like fleet electrification and these megawatt-sized battery packs that need to get charged, I mean, that's like Empire State Building type energy that just has to show up in a parking lot spot area. And if we're actually going to move towards electrification of transportation, all different modes, whatever efficiencies we're able to get out, we should, obviously, to do things as effectively as possible. But is the work going to become less? I don't know. I don't see that right now in the near term.
And I would just add to not underestimate innovation. And if you look back, so from Mayfield's perspective, I can only really speak about solar and batteries. But those two in particular, if you look at IEA, International Energy Agency projections, going back 30 years, we have done nothing but drastically overshoot them in terms of deployment and in terms of cost per watt. And that's currently happening on the energy storage side as well. So while we're also seeing incredibly sharp rises in demand at the same time, we're seeing these really promising technologies that tend to get a lot cheaper the more of them that we build, and there's a lot more demand for those at the same time. So I'd say innovation is really a key and maybe underestimated piece to this.
Mike?
Yeah, thanks, Mike Whittaky. Great talk. Really like the reference to that phased approach for deployment. Just a quick question around that, actually a two-part question maybe. So reliability, are we reassessing how we think about the nines in terms of what gets deployed and what doesn't? Because maybe you don't have that initial grid connection, and we think about the microgrid a little bit differently. And then second part to that, it seems like the technologies are available to support a gigascale compute with a microgrid. I mean, solar plus storage is the cheapest form of energy in the history of ever. And so why are we not seeing that come together more rapidly? So are we reassessing reliability on nines? And then why are we just not seeing this happen? Because we have the technology to do it.
So the microgrid addresses, I think can address two ends of the reliability component. I come from the background of 9 nines of reliability. Previous life, supported the team on the Aegis destroyer, Zumwalt class destroyer, Seawolf sub design, to the Ronald Reagan carrier, and a lot of other infrastructure, including the National Aerospace System. So human life and safety. Can't lose power. You can spend, but if it goes down, you basically it just can't happen. So having that, and typically all these systems, we didn't call them microgrids back then, we called them mission critical power systems. And they had UPSs and backup generators and a lot of testing on different batteries and the ability for these generators to always be on hot standby and the transients and switch, all this stuff, you're absolutely right. It's all been understood and solved and been deployed, whether it's an offshore oil platform in the middle of nowhere or something where human life and safety is literally at stake. The challenge has been standardizing it, streamlining them so that they can be deployed at scale. You can do that with very specific platforms, like a submarine. It's designed and then you just build them that way. The challenge has been with commercial industrial applications. Every customer has a very specific use case and need. So you can't just show up with a box of something and say, here you go. It always needs a level of customization. So that has been, I think, one of the roadblocks that we've been working to address, is to bring speed and standardization with the flexibility for that customization. Now, to your question around solar and battery. Battery technology's been there, it's proven, works. Solar, we see that being deployed, but it's very geographic specific, right? You first have to be in a place that's sunny consistently. Number two is when you're talking data centers, you're talking, miles of this stuff, right? So, clouds, everything else, but also you got to have cheap land. And not everywhere has land, much less cheap land that you can just deploy it across. So solar battery is a solution, but I think it's geographically constrained to certain areas. And sometimes you have to have facilities and infrastructure in areas where it's not sunny all the time, or just there's a lot of vertical space, but not a lot of horizontal space available to you. So those are some of the challenges, but we definitely do see them, And yes, the technologies exist to supply the need immediately and do so in a way that's sustainable and environmentally friendly as well.
I think I got the signal. We're up on time. One more question. Okay.
Great. So I'm also in the solar and storage space, and we're all processing the budget reconciliation bills, changes to the ITC, and I've been very focused on the ITC, Section 25D and 48E, the third-party ownership portion. But I'm curious in the data center space, especially with hyperscalers, what in the budget reconciliation bill are you focused on? How do you see this impacting your development plans?
Yeah, good question. So we're still digesting the bill as well, but to me, I think we've made this net zero commitment by 2040. We have a track record of deploying our sort of partnerships with renewable developers, clean energy developers, for the last 10 years. And that was through a lot of different variations of the ITC and PTC. So, I mean, we all remember, I think, the old days when that used to roll off and then come back, and then it would roll. And so.
Are you describing the solar coaster?
Yeah. Yeah. I mean, we'll look at our pipeline, but I mean, we are still working very closely with developers to maintain that pathway that we have to net zero carbon. So, and our partnerships with wind, solar, and storage, and now SMRs in the medium longer term, which are also impacted by the bill. I think we're going to be looking at those and how they're impacted, but I think our pipeline is still going to go forward because it's such a big commitment for us.
I think we're done. I'm seeing the waves. Thanks everybody for participating in this live dispatches. You can go back to your seat.